Okay, next thing up, hopefully you can see, it might be a little too hard, but when we're talking about in class, it's pretty straightforward. We have this wonderful little pyramid here called the building up principle or the off-bow principle. And just like in a Bohr model, how we started, filled that first ring, went to the second ring, it's very similar to that. It's a little more in depth though, because there's multiple parts to kind of each ring or energy level. So we kind of, it's called the building up principle because we follow this little green line. It tells us the order that we fill these up in, that we put in. When I say fill these up, these represent orbitals that electrons are in. So we always start with 1s, we go to 2s, 2p, 3s, 3p, 4s, back to 3d. That's why when we talked about like how many electrons can fit in the 8th ring, well, it can actually fit 18, but it fills up 8, goes to the next ring before coming back. That's why we kind of downplayed that in Unit 3, but we're going to kind of deal with it a little bit more now in Unit 4. So we use this for a lot of things. One of the things we can create instead of a Bohr model is what we call an orbital diagram. It's a little better illustration of the electrons. And so all we do, we start at the bottom of our building up principle of our pyramid, and it always starts with 1s. So we're simply going to make a little blank with 1s underneath of it. We would find hydrogen on our periodic table, okay? Find hydrogen top left. It's got atomic number 1, which means there's 1 electron. So what we do is we put 1 up arrow to represent that 1 electron. And actually it is correct to only put half the arrow. That is fine to do. That would be the orbital diagram for hydrogen. 1s with 1 electron. Each line can hold 2 electrons. One that can spin one way, one that spins the other. So lithium, which has 3 electrons, will start the same way. 1s, there's 1 electron, there's 2 electrons. We go up, and then there's a down electron. After 1s, we go to 2s. And we're going to have simply 1 electron there. Okay? Pretty straightforward. Carbon is going to also have 1s. It has 6 electrons total. 2s, 3, 4. After 2s comes 2p. Now when we get to p, we actually draw 3 different blanks for that one, okay? And just like we talked about before, how we want to put 1 on each side of that Bohr model before we start pairing, it's the same thing here. We want to go there and there, okay? So 1s, 2s, 2p, put 1 on each of the blanks. That's our 6 total. We do not want to pair it up yet. We'll do that later. Iron, 26 of them. 1s, 2s, 2p, there's 5, 6, 7, 8, 9, 10. After 2p comes 3s, which is back to 1 blank. 3s to 3p. Once again, p will have the 3 blanks. We're at 12, 13, 14, 15, 16, 17, 18. After 3p, we go 4s, 19, 20, and then we have 6 left. We're going to go from 4s to 3d. D has 5 blanks. There's 21, 22, 23, 24, 25, back to 26. It's kind of weird at first, but once you get going on them, it's literally the same thing every time. You build up exactly the same way. There's a lot of shortcuts if you get the hang of it. It is a lot of arrows, but like I said, it's not too bad. Kind of fun.